So let's take a look at derivative rules for all functions. Now in this video, when I give out the formulas, I'll be using four main terms. The first one is c, which is just a constant. The next one is x, just the variable x. I'll have two functions, u, and another function, v. So if I say u prime, that just means the derivative of the function u, and v prime just means the derivative of the function v. So I'm just going to go in order here from 1 to 12. So starting with number 1, the derivative of a constant, remember, is always going to be 0. For number 2, the derivative of a constant times x is just going to be equal to the constant. The derivative of constant times a function u. Now remember, we can bring this constant outside of the derivative and rewrite it as a constant times the derivative of u. The derivative of u is u prime, so we have the constant times u prime. So now number 4 is just a sum and difference rule, where when we take the derivative of one function u plus or minus another function v, we can write it as u prime plus or minus v prime. For number 5, we have derivative of u times v. That's the product rule, where we take the derivative of the first function times the second function unchanged, plus the derivative of the second function times the first unchanged. Now number 6 is u divided by v, so that's the quotient rule, where we take the lower function times the derivative of the higher function, minus the higher function times the derivative of the lower function, all over the lower function squared. Now for number 7, we have the derivative of a function u raised to a power n. Remember, this is just going to be the power rule combined with the chain rule, where we bring the power down, keep the inside function the same, subtract the power by 1, and then multiply by the derivative of the inside function. Now for number 8, the derivative of e raised to some function u is going to be e to the u times u prime. For number 9, derivative of ln of u is going to be u prime over u. For number 10, the derivative of a to the u is going to be a to the u times the natural log of a times u prime. For number 11, the derivative of log base a of u is going to be u prime over u times the natural log of a. For number 12, this one's a new one. The derivative of the absolute value of some function u is going to be u over the absolute value of u times u prime. So now from 13 to 18, we have the derivatives of trig functions. So number 13, derivative of sine of some function u is going to be cosine of u times u prime. The derivative of cosine u is going to be negative sine of u times u prime. The derivative of tangent u is going to be secant squared of u times u prime. Now for number 16, the derivative of secant u is going to be secant u times tangent of u times u prime. For number 17, the derivative of cosecant u is negative cosecant u cotangent of u times u prime. And then for number 18, derivative of cotangent u is going to be negative cosecant squared of u times u prime. Now from 19 to 24, we have the derivatives of inverse trig functions. So starting off with 19, the derivative of inverse sine of u is going to be u prime over the square root of 1 minus u squared. Number 20, derivative of inverse cosine of u, remember that's just the negative version of inverse sine, so it's going to be negative u prime over the square root of 1 minus u squared. Now, derivative of inverse tangent of u is going to be u prime over 1 plus u squared, and derivative of inverse cotangent is just the negative version of inverse tangent, so that's going to be negative u prime over 1 plus u squared. Now for 23, the derivative of inverse secant of u is going to be u prime over absolute value of u times the square root of u squared minus 1, and derivative of inverse cosecant for 24 is just the negative version of inverse secant, so it's going to be negative u prime over the absolute value of u times the square root of u squared minus 1. And then finally for number 25, we have the derivative of a composite function f of g of x, where once again g of x is the inside function and f is the outer function. So this is just the chain rule, where we take f prime g of x times g prime of x. So once again, we take the derivative of the outer function first, keep the inside function the same, and because it's a chain rule, we multiply by the derivative of the inside function.